Alright, this is video for trig ratios. They're back. If you don't remember trig ratios, they're from our happy geometry past. We're going to sit down here and talk about it. I'll be honest, guys, we need to get some better results on people watching these on time. So again, I'm going to reiterate, please, okay, watch these now. If you're watching these late, if you're watching this late, okay, this is not the way to do this class. All right, now that I said, let's worry about trig ratios. Here we go. Okay, hey, you're going to learn stuff, and you're going to do it by discussing the rules, but with me tomorrow. All right, so here are trig functions. These are ones that we've seen in the past, and they got these weird crypto things on here, sine, cosine. Okay, if you don't remember, let's talk about these for a second. Sin, it's not pronounced sin. This is actually an abbreviation for sine. This is not cos, we call it cosine. And COS is an abbreviation for cosine. Tan, it's not tan. Okay, we pronounce this tangent, theta. And these other trig functions are related to them. If you take a look over here at sine, it says OPP over HYP. This one's HYP over OPP. They're reciprocals of each other. And that sine, we call this one cosecant. We don't call this sec, we call it secant. And again, notice here on secant, this is a reciprocal of cosine. Ag over hype, hype over a j. We'll get to what those abbreviations mean shortly. Last but not least is cotangent. That's not coat or cot. This is cotangent. So what about these ratios? What do they talk about? I'm glad you asked. So what they talk about is if I have a triangle, and you guys should have a triangle there as well, and they sit down here and they label this one here theta. I need to be able to talk about which ones are which are my sides. The key point here, all of these are on right triangles for right now. So all you have to worry about is right triangles. And what they're saying is that this sine of theta is OPP, that stands for opposite. Opposite of theta. Here's theta, opposite, I always draw. And that's opposite. It's across from theta. So then we have two other ones, HYP. Okay, hype. The hype one is for your hypotenuse. Again, which one's my hypotenuse? This is from 6th grade. Across from the right angle, there is my hypotenuse. Last but not least, you have your adjacent side. Your adjacent side is a part of theta that is not the hypotenuse. Oh, well, here's theta. This makes up theta. It's not the hypotenuse, so this must be the adjacent. So the question is also, how can I memorize these? What's a nice way to memorizing them? What they are, and just try to suck it up and do. Again, I'm glad you asked. Hopefully you remember the phrase so, ka, toa. And if you take a look, so stands for sine, opposite hypotenuse, opposite hypotenuse. Oh, cosine is adjacent over hypotenuse, and toa is opposite over adjacent. Okay, now we have that in there. Let's run a couple of examples and see what we can do. Okay, first thing that you can come up with is, hey, what if I give all the sides of a right triangle? I want to find the exact values of all 6 trig functions. So again, I'm going to write these all out. So I have sine theta. cosine theta, tangent theta, and then I have cosecant theta, secant theta, and cotangent theta. And using the cheat sheet above, or SOHCAHTOA, I know that sine is opposite over hypotenuse. Well, which one's opposite and everything like this? Well, the way I do it is I go, well, shoot, the one with the right angle across from that, that's my hypotenuse. The one across from theta, that one is opposite. And then the line that is adjacent to, or is adjacent because it's part of theta, and it's not the hypotenuse, so that is my adjacent side. So that I have that, I'll just plug and chug. 33 over 65. Cosine of theta is adjacent over hypotenuse, 56 over 65. Tangent is opposite over adjacent, 33 over 56. That's it. How does cosecant work? Well, cosecant we said was the reciprocal of sine. So the reciprocal means you flip. 65 over 33. Secant is the reciprocal of cosine. So it's 65 over 56. And cotangent is the reciprocal of tangent. 56 over 33. Whew. Not hard, right? Just got to remember how to label. So most of these we're just going to hop right into our word problems. How do we use these in the real life? This is actually how a lot of things are done as far as surveying. Now, mind you, I'm not walking around the street like this problem here and going up to the building. I'm about 300 feet away from that building. I'm looking up at it at about a 65-degree angle. I wonder how tall that building is. No, but they do measure things this way a lot of times. All right, so here we go. From a point 340 feet away from a base of a Peachtree Center Plaza in Atlanta, the angle of elevation to the top of the building. Right here's the angle of elevation. Why is it elevation? Because I'm looking up to the top of the building is 65 degrees. Find the height. Again, angle of elevation goes up from horizontal. So I make a triangle out of this. I make a little triangle. Where's my right angle? It is right here. Okay, so let's go first and label what our hypotenuse is. Great. And now this is my angle, so I have to label opposite and adjacent. Again, adjacent's the easy one for me because it's the one that's attached to the angle that is not the hypotenuse. There's adjacent. Opposite's what's left over. OPB. And what I want to do is I want to take one of the ones I know, adjacent, and opposite. And I want to be able to sit down there and think about, I want to know H, and I know adjacent already. I know those values, or want to know those values. Do I care about the hypotenuse? No. So which trig function am I going to use that uses the adjacent and the opposite? Adjacent and opposite. So I go back up there and look. I have two choices. My two choices are tangent theta and cotangent theta. How do I choose which one to use? I'm going to say choose sine, cosine, or tangent. Why? Because those are in your calculator and we can take care of that. So how do we do this? The first thing I do is I go, well, I'm going to use tangent. Again, what is tangent? Tangent is opposite over adjacent. I know adjacent. I want to find out opposite. So tangent, what's theta? Theta, ooh, that's my degree measure. 65 degrees. Okay, opposite over adjacent is equal to h over 340. And you just solve for h. Multiply 340 by both sides. 340 tangent of 65 is equal to h. And we go and plug it in our calculator. I'll be right back with the calculator. Alright, now that we have our handy dandy calculator, first thing we have to do is make sure that we're in degrees. Okay, because we're in degrees, we're dealing with degrees. So I have to hit mode on your calculator, and no matter which calculator you're in, they will always do these in two things. You have radians, which is flashing up right now. We're going to deal with radians later. So we're going to go ahead and go back up here, hit degrees, press enter. Now that I'm in degrees, it's simply as punching in. So I do 340 times, you don't have to put the times, you just put tangent, and 65 degrees. Type it in, press boom, 729.132. So I go back over here, equals 729.132. And there I go. There's my answer. I'm done. So, how are we going to do with the rest of these? Well, it's up to you. Here's a problem I want you to do. I want you to do it on your own. You can pause me. I'm going to put down the right answer, and you'll see it. So if you're on YouTube, you pause now. Edpuzzle, I'll pause for you. And boom, there's your answer. Okay, if you need more help than that, or more information, come ask me after, or in the questions box, all right? Here we go. Next problem. Here's another problem for you. Exact type of same thing, except take note, they want to know how tall the tree is. And take note of this right here, this little 5 feet section. Maybe it has something to do or change what your normal answer, normal procedure. I'll see you on the flip side. Again, pause my video right now if this is YouTube. And bada bing, there's my answer. Notice the same procedure, I got 16.865, but I had to go in and add that 5 feet because they're asking how tall is the tree, because I'm standing 5 feet tall. All right, that takes care of that. Let's go ahead and take the next one. Okay, now this is kind of an interesting one. What makes this one interesting is let theta be an acute angle such that sine of theta is equal to 5/6. Evaluate the other 5 trigonometric functions. Okay, so this is where it gets a little bit fun. So this, when they say an acute angle here, the first thing you need to write down is a right triangle like you have in for your notes. And then choose one of these angles. You're guaranteed in this right triangle that both of these angles are acute. Pick which one you want to be acute. I'm going to choose this one. No, let's take it. We've been doing that one the whole time. We'll choose this one. Theta. This time I choose this one. Alright, so let's go ahead, and what I want to do for this, the strategy for this one is I need to go ahead and label my hypotenuse, my opposite, my adjacent. Hypotenuse never changes. There's my hypotenuse. My opposite this time is, or my adjacent, excuse me, this time. The other leg that's attached to the theta. Oh, the other one. Oh, that's this one right here. So this one is my adjacent. And this one over here has got to be my opposite. So what do? Well, let's take the information they gave me. I know that sine of theta is equal to 5/6. And I know that sine is really equal to opposite over hypotenuse. Okay, so I'm going to use that information to tell me here that, oh, okay, well, opposite is going to be 5. Hypotenuse is going to be 6. Ta-da. And then how in God's green earth am I going to find adjacent? Oh, yeah, Pythagorean theorem. Remember? A squared plus b squared is equal to c squared. C is your hypotenuse, so this is going to be 6 squared is equal to, well, the A and the B are my legs. I don't really care. I'm going to choose, I don't know, we'll choose this one to be A. So that means this one's B, 5 squared. And this is a squared, so a squared. So here I've got 36 is equal to 25. And this here is a squared. Subtract 25 from both sides. I get a squared is equal to 11. Take the square root. A is equal to square root 11. Alright, great. Now I have all my sides. Square root 11. Now that you have all your sides, you can go in and find your 6 trig functions. Alright, I want you to go do that now, and I'll pause the video. You can see whether or not you got it right shortly. And bam, there you go. There are your answers. All right here. These are my other 6 trigonometric functions. If you have questions, again, talk to me tomorrow. Let's see what's next. So this one here says find the value of x, round to the nearest tenth if necessary. Alright, so again, let's talk about these. Okay. I want to take a look at this, and I say, well, let's start off with my label. 35 degrees I know is my theta. 7 I know is my hypotenuse. Next I search for adjacent. It's attached to the 35, my theta, and it's the one that is not the hypotenuse. So that must be adjacent. And that one must be opposite, but again, it's across from theta, so there's my opposite. Next, I take a look into which ones I have. I have an adjacent, and I have a hypotenuse. Which one do I want? Adjacent. Which ones use adjacent and the hypotenuse? Either sine, cosine, or tangent. You should look up there. Okay. The more you get at this, you go adjacent to hypotenuse. Oh, it's so it's ca. So it would be cosine theta is equal to adjacent over hypotenuse. And I work the magic here. I fill in and I say here's cosine. Oops. I'm getting ahead of myself just writing numbers. Cosine of theta. What's theta? Theta is going to be my 35 degrees. Is equal to adjacent to x. My hypotenuse is 7. Multiply over 7 cosine of 35 degrees is equal to x. And go ahead, put in your calculator. You'll get an answer of 5.734. There we go. Okay. It's just button pushing at this point. You can do it on your calculator. Next. Your turn. And actually, we'll do this one together. Again, I label everything. And I label, okay, here's my hypotenuse. Hypotenuse. One here is adjacent. Across from it is opposite. I know opposite. I want hypotenuse. Opposite and hypotenuse. Go up there and take a peek. Oh yeah. Sine of theta is equal to opposite over hypotenuse. I fill in what I know. Sine of 41 degrees is equal to opposite, which is 7 over hypotenuse. Oops. Not hypotenuse. I need to call it what it is, which is x. Now in this one here, I can't just simply multiply. You're going to say, well, you can divide by 7. Yes. I'm going to show you another easier way. So when you can't just simply multiply and it cancels out, treat it like a fraction and do, cross multiply. So when I do that, it is now 7 is equal to x times sine of 41 degrees. Okay, well then I could just divide by 7 sine of 41 degrees. So 7 divided by sine of 41 degrees is equal to x. And then go ahead and put that in your calculator and see what you get. And you get an answer of 10.669. Okay. Again, calculator work. Shouldn't be that big of a deal. So now you've seen lots of different problems and we're going to call this good. Okay, and we'll finish this up tomorrow so you don't have to listen to too much more. Talk to you guys later.